Hey everyone, today we're going to talk about quadratics. It's the beginning of the notes for quadratics. Well, what's a quadratic? There's two ways to tell something's quadratic. Algebraically, it has an x squared as its highest power, and we call that highest power a degree. Graphically, it's a parabola. It either is a parabola that opens up, or it's a parabola that opens down. There's two forms of a quadratic. There's vertex form, or something we call transformational form, is this. Y equals a, parentheses, x minus h, quantity squared, plus k. Why is that called vertex form? Because the vertex is hk. And we'll talk about what that means in a second. What's the other form of a quadratic? Y equals ax squared plus bx plus c. This is called standard form, but it's not as helpful as vertex form to graph it. Vertex. Well, what's a vertex? It's the maximum or the minimum point. The vertex is the turning point of a parabola. It's where the parabola changes directions. It can be the highest or the lowest point. The highest point is called a maximum, and the lowest point is called a minimum. Here is the vertex, and it's a minimum because it's the bottom of the graph. Here the vertex is right here, and it's a maximum because it's the highest point on the graph. How do we find the vertex from vertex form? This is extremely easy. It's the h and the k. So, for this example, 2 parentheses x minus 3 quantity squared plus 4. What's the vertex? Well, this is supposed to be minus, so that's already 3, and that's 4. Finding the vertex from vertex form is extremely easy. But what about from standard form? So I have this equation. I need to find the h and the k. H is the opposite of b over 2a. So it's the opposite of this number divided by 2 times this number. And then to find the k part, we plug in what we just found for h into x and solve. So let's try it. Find the vertex of y equals 2x squared minus 8x plus 3. So h equals the opposite of b divided by 2a. That's positive 8. That's positive 4. 8 divided by 4, 2. So to find k, let's plug 2 back into my equation. Two times 4 is 8. I'm sorry, 2 squared is 4, times 2 is 8, minus 16 plus 3. That's negative 8 plus 3. So k equals negative 5. So what's my vertex? My vertex is 2, comma, negative 5. Opposite of b over 2a, and then plug that in to find k. What about the domain and range? Well, the domain is how far the thing goes left to right. Well, since the parabola goes left forever and right forever, or left forever and right forever, it goes forever in both ways. So there's two ways to write this. You could say it goes negative infinity to positive infinity, meaning it goes left forever and right forever. Or another symbol that means the same thing is this. That means all real numbers. It means everything. So every parabola goes left forever and right forever. Range is how far down to up it goes. This is not going to be all real numbers. Look at this parabola. How far down does it go? Well, it goes down forever. How far up does it go? What's the highest point? Well, the y value tells me the highest point, and it's 5. Since it touches 5, we use this symbol, a bracket, to say it goes down forever, but it comes up and touches 5. How about this one? Remember, we read the bottom to the top. What's the bottom of this graph? The negative 3. And it touches it, so it gets a bracket. What's the top of this graph? It goes up forever, so it's infinity. Okay. Domain is all real numbers for a parabola, but range will have a negative infinity or positive infinity in it. How do I convert from standard form to vertex form? Find the vertex, identify a, and then rewrite the problem in vertex form. Once you have the vertex, it's very, very easy to write in vertex form. Let's convert this to vertex form. H equals opposite of B over 2 times A. That's 3 halves. Okay, that's 3 halves squared minus 3 times 3 halves plus 4. Learn how to work with fractions. That's 9/4 minus 9 halves plus 4. What's a common denominator for 4, 2, and 1? 4. So that's 9/4 minus 18/4 plus 16/4. That's minus 9 plus 16 is 7/4. So my vertex is 3 halves and 7/4. My A value in this problem is just 1. So y equals A, I don't have to put the 1, x minus the h value squared plus the k value. And that's going from standard form to vertex form. How about the other way around, from vertex form to standard form? We're going to FOIL out the parentheses or distribute them out. We're going to combine like terms, and we're going to write in standard form. Let's try this one. 2x plus 3 squared plus 4. To square something means write it twice, and we'll distribute it in a second. And now we distribute. That's 2 times x squared plus 3x plus 3x plus 9 plus 4. These two will go together and make 6x. So let's distribute the 2 in. 2x squared plus 12x. That'll be 18 plus 4 is 22. And now it's in standard form. So from vertex form to standard form, just multiply everything out and combine like terms. What's the y-intercept of these things? Well, to find the y-intercept of anything, we plug in 0 for x and solve for y. So in this first example, if I want to plug in 0, I would get negative 4 times negative 1, because 0 minus 1 is negative 1, squared plus 3. So what's the y-intercept? Negative 1 squared is 1, times negative 4 is negative 4, plus 3 is negative 1. So my y-intercept is negative 1. It's even easier in standard form. If you plug in 0, I would have 0 minus 0 plus 7. I'd have 7. In standard form, it's just the last number. How about Xintercepts? Well, we're going to spend a lot of time talking about this later on. For right now, let's figure out how to do it on the calculator. So here are the steps. y1, we're going to put the quadratic, and y2, we're going to put 0. We're going to graph, and we're going to zoom so that we can see both intercepts. We're going to hit second trace 5, move closest to the x-intercept. We're going to hit enter 3 times, and then we're going to repeat for the other intercept. Become very good at this process. We do it a lot this year. Let's find all the intercepts. Well, let's do the y-intercept first because it's the easiest. The y-intercept means plug in 0 for x. 0 plus 0 minus 10 is negative 10. That one's easy. Now to find the x-intercepts, we'll do what we just said to do. Go to y equals. Plug in our parabola, 2x squared plus 8x plus 10, minus 10, and 0 for y2. Graph it and see if they cross. Hey, it crosses twice, right here and right here. Second trace 5, and let's move over towards that first intercept. That's pretty close. Hit enter 3 times. And my first one is negative 5. Repeat, second trace 5. Now let's move over towards the other one. That's close enough. Hit enter 3 times. And this one tells me x equals 1. So the x-intercepts are x equals -5 and x equals 1. What's the axis of symmetry? Well, a parabola is symmetric. It means that it's the same on both sides. So I want to find the axis that splits it in half. The axis is the imaginary vertical line through the vertex that bisects the parabola. The axis of symmetry is just x equals whatever the h value is. So in this example problem down here, h is the opposite of b over 2a, or -3/4. I don't even need to find the k value. My axis is just x equals 3/4. So if they ask for the axis of symmetry, it's just x equals whatever your h value is. Increasing, decreasing. This is a little bit confusing, and we'll spend more time on this later in the year. But it's where the function is going up, which is increasing, or going down, where it's decreasing. We use the x values and we read left to right. The left side always starts with -infinity, and the right side always ends with +infinity. It changes at the vertex. So from -infinity to h, and then from h onto infinity. Let's take a look at this problem. Find the intervals of increasing and decreasing. Well, let's just sketch a rough idea of what this graph looks like. This is a parabola with a vertex at 3, 5. Looks kind of like this. Okay? What is the first side doing? What is this side doing? It's decreasing. Well, what about this side? It's increasing. What's the x value where it changes directions? At 3. So we say it is decreasing first. From the left side to x equals 3. Now, I will never write it like that. What notation means left side? -infinity to 3. Yes, it touches 3, but it's not decreasing at 3. It's flat at 3. That's 3 is the bottom. We say it's increasing, then from 3 to the right side. Again, I'll never write it like that. How do I say from 3 to the right side? It starts increasing at 3, and it goes to the right forever. So it's decreasing from -infinity to 3, or from the left side to 3. It's increasing from 3 to infinity, or from 3 to the right side. If the parabola was upside down, it would increase first and then decrease second. So pay attention to which way it looks. This one is an example of one that goes down. This parabola, we need the vertex for. So h equals opposite of b over 2a. So that's -2. K equals -2 times -2 squared minus 8 times -2 plus 1. 4, -8 plus 16 is 8, 9. So this parabola looks like this. It's got a vertex at -2, 9. And because it's negative in front, it goes down. So what's it doing first? It's increasing. So it's increasing from the left side to which point? Do I use the -2 or do I use the 9? We always use the x value, -2. And then we say it is decreasing from -2 to the right side, or infinity. So it increases first from the left side to -2, and then it decreases from -2 on over to the right side, infinity. And that does it for notes on vertex form and standard form of quadratics. We'll spend a lot more time talking about this, so if you have any questions, please ask me. Thanks, guys.